So in curves, our next topic is roulettes. We already come across with the type of curves are several types. One is circle, next conic sections, next roulettes, next spirals. Okay, so circle, conics we already completed, ellipse, parabola, hyperbola. Now roulettes. After roulettes, next spirals, and another special curve is also there. I will tell you, I will let you know after the completion of all these curvatures. Okay, so what is meant by roulette? A roulette is nothing but the path traced out by a point located on the curve in which the curve rotates on another curve, in which the curve rotates on another curve. Roulette means the path traced out by a point when it is located on the curve in which the curve rotates on another curve. That means there are how many curves? To form a roulette, there should be two curvatures. Let us say these are the two curvatures. This is a curve and this is a curve. Okay, now what happened? According to the definition, located on the curve in which the curve rotates on another one. A curve should rotate on another one. That means one curve should be fixed, one curve should be moving. Okay, so let us say this is curve A and this is curve B. Curve B is fixed and curve A is rotating like this. Curve A rotated like this or curve A rotated like this. Then if I locate at any point here, then how that point will move? The point will move like this. This is position P1, this is position P2. The point will move like this. This is the curve and it rotates like this. Okay, this is how it rotates. Okay, just telling you about for the idea. Okay, two curvatures should rotate like that. How many curvatures are there? As we know, in general there are only two curvatures. The first curve is the curvature which is having infinity radius, which is having infinity radius. Next second curve is which is having finite radius, which is having finite radius. The curve which is having infinity radius is nothing but straight line. The curvature which is having some finite radius is nothing but circle. It is nothing but circle. Okay, so as one radius, as one point, I mean as one curve should rotate on another curve. So let us say there are two curvatures. One is rolling curve and another one is directing curve. Let us say this is as directing curve and this is as rolling curve. Okay, so as rolling curve is rolling over directing curve, so that's why we can say directing curvature radius is more than that of rolling curvature radius. Directing curvature radius is more than that of rolling curvature radius. Is it? No, that's when only it possible. Okay, if a curvature is moving on another curvature, means the fixed one should be more than that of, or it should be equal. Otherwise, if it is lesser than that, then it won't possible. Full rotation is not possible. Only half or quarter rotation will be possible. Okay, so the rolling curve radius is small r and the directing curve radius is capital R. Okay, if see here, there are two possibilities for the curvature. One should be to become a line and another is becoming a circle. Okay, let us say if the rolling circle is finite radius, if rolling circle is finite radius, that means it is small r is equal to, is not equal to infinity. Small r is not equal to infinity. That means rolling curvature is not equal to infinity. The rolling circle or the rolling curve radius is equal to r. That means there is finite radius, there is some radius. and the dissecting circle which is fixed. The radius of capital R is infinity. That means infinity ratio. Infinity radius. The rolling curve radius is finite. That means you will get a circle. The dissecting circle radius is infinite. That means what you will get? You will get a line. So what it is? A rolling curvature. That means which is having finite radius. That means a circle should rotate on dissecting circle. That means infinity radius. That means straight line. So the first condition is the circle should rotate on a line, a straight line. So the curvature will follows like this. The roulette will follow like this. Then you will get cycloid. Then you will get cycloidal curves. Okay, clear? Whenever you will get cycloidal curves, when a circle is revolving or rotating on a straight line, the path traced out by a point which is located on the circumference of the circle will follows a cycloidal curve. Okay, so what if it is reversed? What if this phenomena got reversed? That means rolling circle radius is infinity. Rolling circle radius means infinity. R is equal to infinity. Okay, next. Dissecting circle radius. Dissecting circle radius, capital R is equal to some finite radius R. Some finite radius R. Okay, so then what will happen? This circle will stay like this. Dissecting circle will stay like this. What will this rotating circle will do? It's a straight line. This straight line will rotate. This straight line will rotate like this. See, this is the circle and this is the line. What will happen here? The line will rotate like this. While the line is rotating like this, if you consider any point here, the path traced out by this point will be here like this. It will be like this. Okay, so this is how a roulette will be formed. If a roulette forms like this with the second condition, then the type of roulettes are called it as involute curves. Type of roulettes are called it as involute curves. So now you got where cycloids and involutes are came from. These all are the combination of all the things in roulettes. The roulette is a part of curvatures. Okay, so now you got how the cycloid and involute curves are formed. Okay, it's so simple. If a circle means this is the generating curve. The generating curve have some finite radius. The dissecting curvature have infinite radius. That's why it is line. A circle is rotating on the line, then the path traced out by a point which is located on the circle, you will get like this. It is cycloid. If this reverse, this is the circle and this is the line, then what will happen? On this circle, this line will rotate. It will come like this. Okay, so this is involute. This condition is involute. This is the second condition and this is the first condition. Very, very so important. Okay, most important topics in roulettes. Okay, sir, what if there is no concept of infinity radius? Both are circles. I will let you know now. Okay, so now in our previous condition we look over it, cycloid and involute. Okay, so now I will tell you what if both curvatures are circles only. Both curvatures are circles. If both curvatures are circles, only cycloid is possible, involute is not possible. So that's why I'm going to put this condition in cycloid only. Okay, let us say, suppose a circle is there. If it rotates on a straight line like this, then the path traced out by a point which is located on this circumference will be cycloid. Okay, it might be so many ways. if you put your point here, it will follows like this. If you mention point here, then it will follows like this. In sometimes he will ask you for 1.5 revolution. This is for 1 revolution, and for 1.5 revolution it will be like this. Okay, I will let you know anyway after some time. First let me brief you about all the things. Okay, cycloid is there. In cycloid again, if both are circles, that means rolling circle radius, rolling curve radius is equal to r. Okay, that means it is not equal to infinity. And dissecting curvature radius, capital R is also not equal to infinity. That means both are finite. Both are finite means both will be circles, but dissecting circle will be a fixed one and rolling circle will be a moving one. So that's why dissecting circle will be greater than or equal to, it should be greater than or equal to rolling circle. If not, it's possible. Let us say if a circle, there is a circle, there is a dissecting circle. On this dissecting circle, a generating circle is rotating like this. Okay, see, if a circle is rotating on a straight line, then the curvature follows like this and it is called it as cycloid. Okay, if a circle is rotating on another circle outside to it, see here what happened, it is outside to it, it is rotates for 1 revolution, then what will happen, the curvature will follow like this. The curvature will follow like this. Okay, the curvature known as, if circle rolls over another outside, then that is known as epicycloid. This is known as epicycloid. Okay, why? Because of epi means outside. Okay, so it is epicycloid. Okay, next, what if it is rotates on inside? What if it rotates on inside? Then you will get hypocycloid. Then you will get hypocycloid. Okay, in all these conditions we located point on the circumference of the circle. There is another condition also. The point is outside of the circle. The point is outside of the circle. The point is outside of circle. Then what you will get? Superior trochoid. Then you will get trochoid. That means if a point is located outside of the circle, then it will follow like this. This is called it as trochoid. Okay, I will let you know after some time. First of all, you please go through it. A circle is rolls over another circle outside, then you will get epicycloid. Inside you will get hypocycloid. What if both are same? What if capital R is equal to small r? What if capital R is equal to small r? That means both circles radius are same and one is rotating on another, then you will get chordoid. Then you will get chordoid, which is known as cardiac curve. Which is known as cardiac curvature. Okay, this is about Roulettes and its concepts. I will give you brief classification, in-depth classification, where you will get to know about all the things. Okay, so I will tell you in-depth analysis of this Roulettes. Okay, so Roulette means a curve rotates another. A curvature rotates another curvature, then you will get Roulettes. Okay, in this there are two concepts. Small r is rolling, capital R is dissecting. Okay, again there are two conditions. What it is? Small r is equal to circle. Okay, capital R is equal to straight line. Small r is equal to straight line. That means it is equal to, the radius is equal to infinity. Then what you will get? You will get a cycloid. You will get a cycloid. But here small r is equal to straight line. Capital R, the dissecting circle. I mean the dissecting curve is circle. That means it is finite radius, it is infinite radius. What you will get? You will get involute. You will get involute. Okay. In involute there are not much concepts, but in cycloids there are. In cycloids again there are different types. What are they? What are they? If small r rotates on capital R, small r rotates outside capital R. That means rolling circle rotates outside of the dissecting circle. Then what you will get? You will get epicycloid. If it is inside, you will get hypocycloid. Both are common, you will get cardioid. Nothing but cardiac curve. Cardiac curve. Okay. Again, there are certain types in this. Okay. If a cycloid, this is all about the orientation of the curves. But according to the orientation of points, they are different. Okay. If the point locates outside, if a point locates outside, then what you will get? In cycloid only, what you will get? Trochoid. What you will get? Trochoid, either outside or inside. If it is not on the circumference, you will get trochoid. Okay. So for the epicycloid, what you will get? That means epicycloid means that is rotating on another circle. Trochoid is rotating on another circle. The point is located outside. Then what you will get? Okay, not here. I will write it here. These are the another things. Trochoid. In trochoid, again, I am using different color pencil, different color marker. Okay. Point outside. Point is outside. Okay. Point, if the point is outside and rotating on another circle, then what you will get? Superior trochoid. Okay. Point is outside. If the point is inside, you will get inferior trochoid. You will get inferior trochoid. That means cycloid means like this. Trochoid means point is located outside. It will be like this, or it will be like this. If it is inside, it will be like this. It will be like this. Okay, this is about trochoid. Sir, are these trochoids are applicable for epi and hypo also? Yes, of course. Okay, superior epi. This is called it as superior epi trochoid, and that is known as inferior hypotrochoid. And again here also superior hypotrochoid, inferior epitrochoid. The conditions are same. This is dissecting circle. If it is located like this, then what you will get? Superior epitrochoid. Okay. If it is inside, inferior epitrochoid. In the same way, there is also hypotrochoid. Okay. Clear? So this is about Roulettes. Now I will tell you clear picture about cycloid, how cycloid will be drawn, how epicycloid is drawn, how hypo and chordoids will be drawn. Okay. So now the topic is cycloids. Okay. Cycloid means what it is. If a circle rotates on a horizontal plane, then the path traced out by a point when it is located on the circumference of a circle. Let us make this definition in a good manner. The locus of a point, which is located on the circumference of a circle, and the circle rotates on a horizontal plane for one revolution without slipping. The condition is more clear, without slipping. Okay, so without slipping it should rotate. Okay, like how, suppose there is a horizontal line and it's a circle. Let us say this is the center point and this is the radius, this is the point P. Okay, so now what happening, this circle is rotating on a straight line without slipping. If this circle rotates without slipping, then what will happen, the locus of C will not change, it will be parallel to the straight line itself only. Okay, now what's happened, this is the circle, this is the P. Now what happened, the circle is rotating, suppose it came to this position, then what will happen to this chord CP, at least it will move like this. This CP is like this here, and if circle takes this position, what will happen, the P will move like this, okay, and at half revolution what will happen, this one will come up, this CP is in down and this CP will come up. After one revolution this will come down. So by joining all these positions you will get cycloid. How to draw this cycloid, I will give you that description in my I will give you that link in my description. Okay, so this is cycloid and there are different orientations. First of all, circle and the point is located on the bottom. If the point is located on the bottom, the cycloidal curve will follow like this. If the point is located on the top, then it goes like this. If the point is located, if the 2 points are located, then this is okay. And not only this, they will ask you, the circle is rotating half revolution horizontal plane and remaining half on vertical plane. Okay, then what will happen, the point is here, it will come like this and end it like this. Okay, so this is what the orientations of cycloids. Okay, and in cycloids there are several types. One is epicycloid. Epicycloid means there is a very big directing circle, then a rolling circle. If it rotates, see this R is smaller than capital R. If it rotates, what will happen? It will not cover its entire capital R with one revolution of small r. With one revolution of small r, you cannot cover the total capital R. It will cover a bit like this maybe. Okay, for one revolution. Okay, so what will be there then? It looks like as a sector. The circle is rotating on a sector of the capital R. Okay, it rotates on the sector of the capillary. Then sir, how to find out this angle theta? This angle theta is nothing but small r by capital R into 360 degrees. The ratio of rolling circle and the ratio of directing circle multiplied by 360, then you will get this angle theta. In the same way for hypocycloid, it will be like this. For epicycloid, it will be like this. Okay, this is for epicycloid, this is for hypocycloid. Okay, so now what happened is, this is epicycloid, this is hypo now. Then what happened if both circles are same? Both circles are same radius. Then what will happen? I locate the point here. Then what will happen? It will follows like this in a love symbol. That's why when a circle is rotating on another circle which is equal to the same, which are equal radiuses, then the cycloid will be, the formation will be chordoid or cardiac or the cardiac. There is another very important position in hypocycloids. Okay, you all know this is hypocycloid, but there is a very important thing in hypocycloid. What it is, I will tell you, I will let you know. So the next topic is about hypocycloid. Okay, in hypocycloid, the main thing is to see couple. The main thing is to see couple. Okay, you already gone across with this to see couple. Why? Because of in ellipse, the hypotrochoid. Hypotrochoid of to see couple is an ellipse. Okay, now here also there is another to see couple. What is that to see couple? What is to see couple means? There is a generating circle and directing circle. If the generating circle, if the generating circle's diameter, the generating circle's diameter is, if the generating circle's diameter is half of the directing circle's diameter, half of the directing circle's diameter, then to see couple will form. Then to see couple will form. Okay, so then only to see couple will form. Say this is generating circle, this is half of the directing circle. That means directing circle's diameter is twice than that of generating circle. That also you can write. Directing circle's dia is equal to twice than that of generating circle. Like this also you can write. Okay, if you rotate the circle like this, then what will happen? The point will trace like as a straight line. Even if you want, you can try. You can try it. Even if you try the process, it will forms like a straight line. So hypocycloid of a 2C couple is always a straight line. Most important thing in Roulettes. You can get a question from this concept. Hypocycloid of a 2C couple is always a straight line. Otherwise, what is 2C couple? 2C couple means the directing circle diameter should be twice than that of generating circle. If not, the generating circle diameter should be half of that of directing circle's diameter. Then the 2C couple formation will be formed. Okay, so then only you will get a straight line. Okay, for hypotrichoid you will get ellipse. Okay, please don't get confused. If it is for hypocycloid, then you will get straight line. If it is for hypotrochoid, then you will get ellipse. Hypotrochoid means it should be outside or inside. Okay, either inferior or superior. Okay, a most important thing in hypocycloid. So the next topic is spirals. Spirals is also one of the kind of curves. In curves, there are different kinds. In curves, circle is there, conics are there, roulettes are there, and these are spirals. For conics, the conic sections are obtained from sectioning a right circular cone with a section plane. And for roulette means when two curves are rolling or revolving with each other by fixing one of the curvature as a fixed one, and if another curvature moves around it, then roulettes will be formed. Spirals means it is the locus of a moving point. It is the locus of a moving point. It's most important. This is the locus of a moving point in small words. Okay, but we should learn it in a specific way, like in it is the path traced out by a point, moves along a straight line, when the line is rotating about a fixed point, okay, and based upon the velocity or the motion, of the moving element. Spirals are divided into two categories. One is Archimedean and another one is logarithmic spiral. First, let me tell you about how the spiral will looks like. Suppose this is the point. According to the definition, a point moves along a straight line. Okay, there is a point, it moves along a straight line. That means the point is in motion. Okay, the point is in motion, and that straight line is also revolving. Like this. Okay, the straight line is also revolving like this. Then the locus of a point will be, how the locus of point will be, suppose the point came here. This is the position 1. Okay, that is the position 1. Okay, then how it looks like? It will never stay here. Why? Because of the straight line is also moving. So this will be the next one. Okay, and after third position, the line will be moving like this. The position may change here. So like that, it will just move. Okay, so that is the spiral. Let me explain you about Archimedean spiral. Then you will get to know about what is a spiral exactly. Okay, so what is Archimedean spiral? The particle is moving in such a way that the difference in the distances from the pole is constant for the given particular. The pole is constant for the given particular, and the formula is R1 minus R2. That of R1 minus R2 is proportional to the omega t. Omega t means the angle of inclination. Okay, and by revolving this one, see what I am doing is, to eliminate this proportionality, I can use constant k. Omega t minus is nothing but the theta. Okay, so how it looks like? So how this Archimedean spiral form? See, this is a straight line. Let us assume this is a straight line. Okay, and I located one point here. I located one point P here. Then what's happening according to the definition? Point is also moving and line is also moving. Okay, line is moving now. So if line is moves, this is the position 1. Then what will be the position 2? And line is not moving like this. Line is not moving like this. This is not the way the line is moving. The line is moving by fixing 1. Okay, according to the definition, what it is? It should rotating about a fixed point. So that means one of the points at the end of this straight line should be fixed. If one of the points at the end is fixed, then what will happen? The line will rotate like this. If not, it will be by fixing one of the point here. One of the point is fixed point. So line should rotate. That means line is rotating like this. This is the way how the line is rotating. But what happened? Here I located a point. That point is also moving. So that how the curvature will be, let's see. So now what happened? The line moved like this. Position number 2. It came to position number 2. What will happen to this point P? Point P also is moving. So point P will be here, P1. Next, what will happen? It will move up to position number 3. The point will come now. Again the point will move. This is the P2. And next for this, here it will be. Okay, so now what will happen? This will rotate like this. This is how a spiral will looks like. Actually, this is the form. This will be the form. Okay, this is the spiral. Okay, to draw this one, how we are going to draw this one? I will give the link in the. I will give that link in the description. Okay, so no problem. This is Archimedean spiral. In Archimedean spiral, what he is saying is R1 minus R2 is equal to K theta. If R2 is equal to R1 plus K theta, what will happen? The point is moving towards the fixed point. If it vice versa, if it reversed, then what will happen? The point will move away from the fixed point. Okay, these are the main criteria you need to remember. Okay, what is Archimedean spiral? A particle which is moving in such a way that the difference in the distances from the pole is constant from a given particular. Okay, if in this equation, if it is plus, then what will happen? The point is moving towards the fixed point. If not, the point will be moving away. Okay, so next, what is a logarithmic spiral? Okay, logarithmic spiral is nothing but the cyclones what we are watching. The cyclones. Okay, clear? So what will be there? Here the ratios are constant. R1 by R2 is equal to R3 by R4. That is equal to constant. This is the logarithmic spiral. Okay, this is in general way we are watching everywhere. We can observe this thing in in so many aspects. Okay, and especially in the analysis of cyclones. Okay, so and there is another one also, which is golden spiral, the most important thing in the entire drawing conic sections and in entire drawing curves concept. Okay, so now I am going to teach you that. The next concept is golden spiral and golden ratio. Okay, what is golden ratio? Before going to the golden spiral, we should know about golden ratio. What is a golden ratio? Okay, the golden ratio means it is the ratio of total segment to the larger segment. It is the ratio of total segment to the larger segment. So what is this total segment? What is this larger segment? Let us consider a line A. A line is there. Okay, in this line I am dividing this one into two parts unequally, not equal, and here it is not equal. It is unequal. The two parts are unequal. Okay, so let's consider this is as A and this is as B. Okay, then what he is saying is, according to the definition, this A plus B by A, the ratio of A plus B by A is nothing but the golden ratio, and this ratio is nothing but the A plus B by A is always equal to A by B. Okay, that means this is the total segment and this is the larger segment. According to this is the total segment means A plus B. The larger segment is A. The shorter one is B. According to this, what it is? Golden ratio means the total segment to the larger segment. The total segment to the larger segment is the golden ratio, and it is always equal to the ratio of larger segment to the shorter segment. Larger segment to the shorter segment. So in other words, what I can say is A plus B by A is equal to A by B. A plus B by A is equal to A by B. So what is the use of this golden ratio? Why should we learn in drawing? Why? Because of all the practical things in the world follows this particular golden ratio. Okay. See, if you consider Earth, how it looks like, it's not actually circle. It's not in a circular shape. There is such kind of little bit ovality nature is there. Okay. So if there is ovality nature, what will be there? There will be a radius, there will be another radius, there will be two radiuses. Okay. Even if you consider your face is not exactly round. Your face is little bit like this. A person's face will be like this. Of course, I'm not good in pictorial graphics. I'm good in engineering drawing only, not good in normal drawing. See, suppose this is, if let us assume this is a face of the guy, then what's happening is there will be a radius here and there will be another radius here. There are two radiuses. Okay, if you consider in lengthwise, even if this is a total segment, even if there is a total segment of R1 plus R2, still there is such kind. R1 is there, R2 is bigger than R1. Still R2 is bigger than R1. Our face, okay, and our total height, even if you consider from the middle point, okay, if you consider our height, it follows the same rule. It's not equal, okay. So all these things follows this. All the things follows this equation. So what is this equation? Let me tell you. A plus B by A. So what I am doing is 1 plus B by A is equal to A by B. I am assuming A by B is equal to 5. I am assuming A by P is equal to 5. So 1 plus 1 by 5 is equal to 5. 5 plus 1 is equal to 5 square. Okay, 5 plus 1 is equal to what will be there is 1 plus 5 by 5, sorry, 5 plus 1 by 5 is equal to 5. So 5 square is equal to 5 plus 1. So 5 square minus 5 minus 1 is equal to 0. If you solve this one, you will get phi as 1.612. You will get phi as 1.612. So in your face, if you consider the segments, the ratio will be as 1.612. The ratio will be 1.612. See, let us consider in your face, from here to here it is A, from here to here it is B. Okay, so A by B will be always 1.612. Okay, and even if you consider your height, from here, from your nabi to this height is different, from here to this height is your foot height is different. If you take the ratio, it will follows 1.6182. 1.6182. This is the golden ratio. Okay, so and not only so this is what golden ratio is. The golden ratio means the ratio of larger segment to the shorter segment. Okay, it's nothing but the golden ratio. Okay, and the golden ratio value is 1.6182. Okay, there are no units for this. It indicated with 5. Okay, so the spiral, what is the golden spiral? The spiral which obeys golden ratio. The spiral which obeys the golden ratio is golden spiral. Okay, not only this golden spiral, Fibonacci series also follows this golden ratio formula, golden ratio principle. How, sir? So what is the Fibonacci series? 0, it's 0, 1, 1, 2, 3, 5, 8, 13, next 21, next 34, okay, next 55, okay, like that. Fibonacci series means 0 plus 1 is equal to 1 and 1 plus 1 is equal to 2, 2 plus 1 is equal to 3, 2 plus 3 is equal to 5. Like that the Fibonacci series follows. Okay, if the ratio of any two will become, if you take the ratio of these two, then it will become 1.6182. Okay, if you take the ratio of these two, it will follows 1.6182. Okay, not only this, the Fibonacci number series also follows the golden ratio. So how a spiral will form, then I will show you. Fibonacci number series 0, 1, 1, 2, 3, 5, 8, 13, 21, 34, 55, 89. Okay, okay, here 0 plus 1 is equal to 1, 1 plus 1 is equal to 2, 2 plus 1 is equal to 3, 2 plus 3 is equal to 5. Okay, how now I will let you know how this Fibonacci series also will form a golden spiral. I will let you know. Let's take a rectangle of 34 by 21. Let's take a rectangle of 34 by 21. Here what I am doing is 34, 21. After 34 and 21, next what number will be there? 13 will be there in lower side. In lower side, okay. 21 will be there. So this is the, if this is the entire 34 length, I'm just considering this one as the 13th part. Okay, so this is total 34. 13 also will be there in this only, no? Okay, okay, this will be the 21 and this will be the 31. Like that I divided. Okay, so now this is 13. Okay, now in this 13 I am taking 8. In this 13 I am taking 8. Okay. Okay, now this is 13 and this is 8. That means this is 13 and this is 8. See how many rectangles now I made? 1, 2 and 3. Okay, clear. Next, in 8 again what I am taking? 5. This is 8 and this is the 5. This is 8 and this is the 5. Okay, in this 5 again I am taking third part. This is 5 and this is the third one. Next in this 3 I will take 2. Okay, like that I will take 1 and 0 also. Okay, now join all these points up to 2. This forms a golden spiral. This is called as a golden spiral. Okay, so this is common. Phi is equal to 1.6182. We can take it up to 1.618. Okay, the ratio will be same for all. Okay, clear? The next concept is, next type of curvature is helix. Helix is nothing but the locus of a point. Helix is nothing but the locus of a point which is moving in an axial direction. The locus of a point which is moving in axial direction when the object is rotating about its axis. When the object is rotating about its axis, then the locus of the point will gives you the curvature of helix. So where we can see how this will happen practically. The best example is nothing but screws. You know screws. In all the screws it follows the same principle. Okay. Okay, here the locus of a point. Okay, that means this is the point. The locus of a point, it should move in axial direction. It is moving in an axial direction. For what? For an object. Let us consider this is a cylinder. Let us consider this is a cylinder. Here what's happening? The point is moving here. The point is here. Let us say this is the point P. The point P is there itself only. It's moving in axial direction. Where it is moving? It is moving in axial direction. But the object is rotating. So that's what will happen? It will follows like this. Is it now? The point is moving, and as well as the cylinder also is rotating in the axial direction. Then what will happen? Obviously the point will move like this. This is how the helix is formed. This is the helix. Okay, now you got to know about what is helix. Okay, so in the helix we come across with helix, spirals and come across with helix, spirals, conic sections, roulettes. Okay, you know, all these curvatures don't change their characteristics. All the curvatures will never change their nature or character. Okay, but there is another curve. One curve is there. One curve that changes its nature. That changes its nature. What is that? You know that? In the classification, I told you there is another curve. A special curve is there that I am going to tell you in the last session. Okay, so this is the last session for this particular topic. Okay, so now all the curvatures, that means ellipse, if you consider the ellipse and parabola and hyperbola or a cycloid or an involute or a trochoid or a spiral or a hypotrochoid and everything. Okay, these curvatures will never change their nature and characteristics, but only one curvature will change its nature, that is oogie. That is oogie. That means the combination of convex and concave. The combination of convex and concave, that's nothing but this is the oogie curvature. This is oogie curvature. Not only like this, you can put it like this also. This is also oogie curvature. Okay, so where we use in constructions, where we use this type of oogie curvature, where we analyze in constructions. Okay, clear? So this is about oogie. And the one thing in conic sections is, the common thing in conic sections is ellipse, parabola, hyperbola. All these three are symmetric in nature. All conic sections are symmetric in nature. Symmetric means if this is a circle, this is symmetric about both x and y axis. If a rectangle is there, then it is symmetric about both x and y axis. Why? Because of, if you fold it, or if you consider the distance from here to here and here to here, from A and B is equal, A and B will be equal. If you consider d by 2, this total will be, the either sides of the axis dimensions are same. That then only we consider it as symmetric in nature. So in ellipse also, from here to here, from here to here, the distance is same at any point. If you consider P1 here, if you consider P2 here, the distance from P2 to here and distance from P1 to here will be same. Okay, like in parabola also and in hyperbola also. So all three conic curvatures are symmetric in nature. You need to remember these things. Okay, so this is about curves. Okay, we come across it with conic sections, we come across it with roulettes, we come across it with spirals, helix, and the special nature oogie curvature. Okay, so you need to remember all these things. Okay, and if you want to see how a roulette will be formed, how to draw ellipse with different type of methods, and how to draw cycloid with different type of methods, how to draw involutes with different type of methods, if you want to see, I'm going to share those links in the description. Okay, you can go through it. Okay, those links are belong to my channel only, where I used to draw the diagrams in drawing board and drawing sheet with the help of mini drafter. Okay, so meanwhile you can share those links also to your friends who failed in this subject. They can have better utilization of my channel. Okay, clear? Thank you.